I could be like, what again? Okay, so today is the 9th, and we, again, are working on factoring, but today we're specifically looking at factoring by grouping. So let's talk about this process. We want to factor out the greatest common factor first. Then, if the polynomial has 2 terms or 3 terms, look for the difference of 2 squares or a perfect square. So if you remember back to last week, how do I identify a difference of squares? Calvin's?
If the middle term isn't there.
If the middle term, that b value term, is non-existent, that means that the difference of squares will cancel it out. How do I recognize a perfect square trinomial? So, Caleb?
I think it's when it's like the whole plus minus situation, and then they have the same A, C, and B, something like that.
I don't know if you're on the right track or not. I can't tell. Michelle?
It's when the last term and the first term are both perfect squares, and then the middle term is like a difference. Yeah.
So if we choose some like value, let's say R. Yeah, your third term should be the value squared, whereas your middle term is 2 times that value. Now it gets a little bit more complicated if there's an A, but that's just the difference between the perfect square and the difference of squares is the middle term gone, difference of squares. That relationship where one is double, one is squared, that's perfect square. So when we look here at 3n cubed minus 12n squared plus 2n minus 8, is there something that we can factor out of all of those terms? 1 doesn't count because that's not factoring out. Calvin?
No.
So no, right? Well, okay, so why is that step 1 then? Okay, there's nothing to factor out, I guess we move on. So there's step 2. Polynomial is 2 or 3, look for, well, I have 4 terms. If there's not something that I can factor out of the entire thing, is there a way that I can split this and factor something out on the first half and something else out on the second half so that whatever's left over is the same inside the parentheses? So if I look at my 3n cubed and my 12n squared, is there anything that could be factored out of those, Megan? 3n squared. So when I see that the entire thing can't be factored, break it. I'm really jealous because I need more of those. Almost all of mine are dried up. Well, actually, I've used them all to the end, and they're gone. So if I factor out 3n squared, I end up with n minus 4. So then what I'm asking is there a way to get n minus 4 out here? And if so, what would have been factored out? Emma? 2. You with me, Straver?
Yeah, my phone was just buzzing.
Who's finding iPhone?
It was my watch. I was trying to turn off the buzzy thing and then press the wrong button.
This now has grouped that these are my one binomial, and with the plus in front of it, and these being the same are my other binomial. So my problem now becomes, crap, write like a pen, please. And guys, this isn't even a trinomial. Now we're able to do this with polynomials that have more terms even than 3. Lynn, what's up?
So, how did you turn 3n to the third to 3n squared?
So, this is, if we think about this as like two different polynomials that we then add together. Let's break this up and look at each polynomial separately. So if I look at just my beginning, 3n cubed minus 12n squared. Let's act like that's like on its own, forget about the rest of it. What we're looking at here is there something common between both of them that I could divide them both by so that I can have some number times a binomial that would get me to this. So just like back when we did like 3x plus 12 to make it similar but slightly different. If I look at 3x and 12, they have a common factor of 3, and I can make this 3 times x plus 4 would get me 3x plus 12 when I do the distribution. You with me on this part? So because when I multiply 3 times x, 3 times 4, I get back to here. We're doing the same process, but now, because they both have variable terms, I can also factor out a variable term. So when looking at the coefficients, 3 is the biggest numerical value that I can factor out. But then if I look at the variables, I have n to the third and n squared. Well, I can get rid of that n squared and do the same thing here. So this 3n cubed didn't become 3n squared. We factored out, like we divided by 3n squared. So that becomes 3n squared. And then we ask what needs to be in the parentheses to get back to my original, which here would have to be n, and here would have to be minus 4. Because then if I do the distribution, I get 3n cubed minus 12n squared. Does that make a little bit more sense? Then we do the same thing with the right part, but we treat 2n minus 8. We say, what can I divide these both by? Well, 2 is the biggest thing I can divide them by. And then what do I have left over? Well, 2 times n would give me 2n. 2 times negative 4 gives me negative 8. Any other questions about that one? Try the got it. When I look at the fact that 3 of my coefficients are even and then my constant is odd, I doubt you're going to be able to factor anything out of the entire thing. Try that on your own. So when I look at 8, 14, 20, and 35, they don't work well with each other. I can break this up and treat it like two separate polynomials that are just added together. I can actually treat this as just 4 different monomials, but that's kind of going way too far. So, Carmen, when you think about the blue polynomial there.
Can I say I did a little bit?
Sure, yeah, okay.
I did it, instead I kind of like switched around the equation, so I did 8t cubed plus 20t.
Ooh.
Because those could both go, like a 4 could go into those. And for the other set, a 7 could. So I thought that would just be easier because they had a common factor.
So then down here, you said you took a 4 out, so 4t probably?
Yeah.
So you took out 4t and you had?
I had 2t squared plus 5.
And then, what'd you take out of it?
I took a 7 out. That way I had the 2t squared plus 5.
T, or yeah, 2t squared, my bad. So as long as these match each other, what's in your parentheses, you're good. But let's see, did we need to rearrange it, and or does it make a difference? So if I look at my 8t cubed and my 14t squared, well, we know the t squared is the biggest t value that I can pull out of there. And for coefficient, I've got 8 and 14, so I can use 2. Now if I pull out 2t squared, what would that need to multiply to make 8t cubed? 4t plus, if I had divided this by 2t squared, well the t squared is canceled, 14 divided by 2 gives me 7. I would have to have 4t plus 7 over here if this is gonna work. How do I go from 20t to 4t? We divide by a 5. How do I go from 35 to 7? We divided by 5. So here that common factor that we divided by was 5. Here that common factor was 2t squared. That's how I get my coefficients. But either route that I take is going to get me to the answer. So notice, it doesn't matter how you group it, as long as the group that you make has a common factor that can be factored out of it. Now this would then tell us, if we're going to just kind of sample chapter 12, our zeros where that parabola hits the axis are going to be negative 7/4. Or this one gets more complicated because the t squared, you have to think of what squared plugged in there would do that. So actually, you just do it the same as normal, but then do square root of it. So it'd be negative 7/4. Or what would it be if that wasn't squared? To make it 0, it'd have to be negative 5 halves, right? So instead, it's the square root of negative 5 halves. So that one's a bit more complicated. This, and actually, are you gonna?
Should it be the negative square root of 5 halves?
Yeah, because you can't square root the negative. But sorry, I got stuck in my head on something because these are not, in this situation, these might be the only two zeros, but what happens to our shape or our graph or our function or whatever you want to say when we have a power of 3? We're not changing the coefficient. You're thinking of when we change the coefficient. Now we change the power.
Or would it get increase the slope?
So what did we have when the power was single? Like 2x plus 5. A line, right? So when the power is a power of 1, we would have 1 point where it crosses the x-axis. At most. Right? We can't have 2 because it's a straight line. When the power is 2, we then end up with potentially 2 points at most, because my parabola could also do this and never touch the x-axis, with a power of 3. Calvin?
It's an S curve, and it can touch at 3 points.
It would at most have 3 intersections. It could at minimum
1.
have 1, because it's got to be continuous, because it's the whole
It goes
function.
infinitely in both directions.
Got to pass that vertical line test. So if it went like this, it could only have 1 intersection. There's your relative maximum. There's your relative minimum. You don't need to understand any of this right now. Just explaining the highest power tells you the largest amount of zeros, like times it could cross the x-axis.
Is 1 always the minimum for, like, actually, no, that's not pretty fair.
So if you only to the power of 4, would it just be like 1 leading line or something?
So it would then, and it depends on a lot of other details. Let me capture this really quick. it would depend on a lot of other details, but it could look something like that.
M. The M curve.
Or then once you do power of 5,
Ah!
does weird things like that. Like, and this is really vague, like really general pictures. All right, let's keep moving on.
5. Oh, I see. You just, every time you just wrap it, and then wrap again, and then wrap
Well, it depends on a lot of other details.
As
In
in,
like, yeah, for where would the maximums and minimums happen? Because it would be modeling like what happened based off the input values. So now, stepping up another power, now we've got 4q to the 4th to start.
Whoa.
We still have a polynomial with 4 terms. Is there anything that could be factored out of all of them? Michelle.
4Q.
By the way, I think you raised your hand too much because you ripped your sweater.
Oh, what? Oh, no.
I'm
this
just
rip
joking.
has been- There's
I-
actually a rip
I'm
over
trying
here.
to
though.
make a joke. The like sweater's ripped
I
right
did
here, so
that
it's like
yesterday.
you raise your
I
hand.
actually-
Never mind. So if we factor out the 4, work with me, please.
4Q.
This will then
4Q. 4Q.
for q. Thank you. Because this last term is not a constant. We don't have a constant here at all yet. So if I factor out a 4q, what this does, it doesn't matter what's in here. Pause for a second. What could make my function 0?
0.
0. Because if I plug in 0 here,
What's
all of this becomes 0. So what that tells you is if there's something that we can factor out initially, one of my zeros will be at the origin. What this tells you, factoring out that 4q first, is one of your zeros is at the origin. Now let's look at what's inside of here. So that will give me q to the 3rd minus 2q squared plus 3q minus 6. So I know, my q's are awkward. Whatever. Judge me.
I always do.
I know, I can always count on that. Michelle, what do you do then?
Then you, well, you take each of those and kind of split them in half and have like the q to the 3rd minus the 2q to the 2nd be its own separate little thing. And then to simplify that further, you can take out q squared.
I follow.
So,
I got you.
all she said to begin with is we can split my polynomial and group it. So we now technically have 3 groups. The 4q is its own group that nobody cares about anymore. We just keep writing it. Because we already figured out the 0 can be my 0, or a 0, and a one of my zeros. Then we can factor out q squared. This is where Michelle started actually doing the work. Between q to the 3rd and negative 2q squared, q squared is common. And then we're left with
Q minus 2.
q minus 2.
And for the other side, you can factor out 3.
3, and we still get q minus 2.
Yay!
And we have to close again because our stacked parentheses.
Okay.
Oh, so we factored even more than we did. I want to see what we did.
So-
I wanna see what we did.
Now we rearrange. Move everything around to clean it up. Yeah, the only difference here is we have the 4q outside. Aside from that, we now have this binomial matching this binomial. So we put those together. Now remember, 4q just keeps coming along for the ride. So we start with this equals 4q times the quantity. So you can do whichever one you want first. Q minus 2 or the q squared plus 3.
We need double print.
I was about to ask you that.
No.
I don't think so.
We talked about this last week, right?
Because if you did double parentheses, then it would.
They'd be put.
Yeah, if you point. Wait, yeah, no, wait,
It
that would
would
make
make
sense.
sense.
You'd have
Yeah,
to look
those
trivial.
Yeah.
So the question is, does it change anything?
No.
The 4q has to multiply into those values.
Wouldn't it multiply
How
into
it's
both
written
terms?
right here. Hold on.
Okay.
How it's written right here. What will the 4q multiply to? Brian.
Wouldn't it multiply to the first one and then those two would multiply to the third one?
So
Doesn't matter
if
what?
if my 4q multiplies into my first one, if I do this left to right, and then these values multiply to my next one,
Yeah.
has the 4q applied to everything?
Yes.
Yes.
Bang.
If I double stack my parentheses, crap,
'Cause then wouldn't it apply?
would my 4q then apply to everything?
Yes.
Yeah. So, it shouldn't make a
You're
difference.
just adding more
Okay.
parentheses.
My advice, leave it like this, it's simpler.
Yes, sir.
Yeah.
Now what we can find out is my zeros could be, so I'm just going to say zeros. Now you guys don't really, you don't have to care about this yet, but my goal is that when we get there, it's super easy, because we've already talked about it. My zeros could be if q equals 0, there, or if q equals 2, or if q equals the negative square root of 3. Because when I square it, I'm going to get negative 3.
I'm confused how we skipped to the
So, hold on. When you corrected me earlier, I do think the negative actually belongs in the square root. Because if you take this squared, negative times a negative makes a positive, and we don't want a positive. If I take this squared, I get negative 3 as my answer. So our negative, even though you can't take the square root of a negative number, that's not what we're doing. We're not trying to solve this. We're saying when squared, it would be negative 3. Yeah, so this right now utilizes the imaginary number because you can't do a square root of a negative. So don't think too much about this right now, but two easy zeros that we found are 0 and 2. Don't worry too much about the imaginary number yet. We'll get there.
So is
It's
that,
not real.
is that the zeros on the graph?
Yeah, so that tells you it crosses the x-axis uno, dos, tres times.
Yeah.
There are 3 zeros possible. Now, if there wasn't the 4q out front, and we only had these, it would only have 2 zeros.
Right.
So maybe that minimum, doesn't... Yeah, we'll get to all those examples.
But it wouldn't be an S curve because it has a maximum power of 4.
Right, so what you should realize is you're either going to have one value that factors out the whole thing, or you're going to have, there's more happening here, because the higher power makes it that S. So try this, got it, on your own. Now you can change the order of it if you really want, because you might notice the 6 and the 12 could work well together, and the 9 and the 18 could work well together. Or you can leave it how it is, and use the 6, 9, and the 12, 18.
Couldn't you factor something out of all of them?
3.
But still, you can change the order if you want to.
See some more.
So, Caleb, you asked the question.
Yes, sir.
What is it that factors out of all of them?
3H.
3H.
Steve, you're such a smarty.
So here's what I was meaning, Caleb, because people asked this in the past. They said, why don't we group the 3 with the 6, because they work well together, and the 2 and the 4, which you can if you feel like rearranging, if you think that's easier, but it doesn't matter, because as we've seen, the factored form will come out the same.
Okay.
So
you don't need to rearrange those.
I remember that little puzzle thing.
But you would still have to group up like that.
I threw my sister a lot.
So if we don't rearrange, this is what I'm trying to, if we don't rearrange,
Well,
and I split this in the
never
middle,
mind.
what's able to be factored out of these two?
Uno.
Just h squared, no coefficient
Oh,
with
okay.
it. If I had changed the order Then I'm able to factor out with a coefficient. But let's just leave it how it is right here. Anyone got this for me? What's the first binomial that we get? We factored out. What did you factor out, Michelle?
H squared.
The h squared.
2h plus 3. And then that's plus 2, and then parentheses 2h plus 3.
So this, in the end, comes out to be 3h times 2h plus 3. I like to use my common binomial first, just to get it out of the way. Then the multipliers that you have left over, the 3h and the 2. And this one,
That's,
did we miss a power somewhere? No, I think we did. Yeah, that's where I made my mistake. Yeah, this 3h. Sorry, I don't know. I looked all the way out to the front. This is actually h squared. My bad. I looked at the wrong coefficient. I tried to do it again. And then we could find our zeros if we needed to. The Jacob's ladders. Yeah.
The time, and then we kind of stopped when he kept gluing his hand to the.
Yeah. Been there before. Before we work for the next few minutes and then run out of time for class. So, why I had started talking about me being gone tomorrow. Because it's a sub, and I have no idea if they understand math. It's a dude named Mr. Cooper.
Sounds
Sheldon Cooper.
he
Not
sounds
Sheldon.
cool, per.
So, tomorrow, you are going to start the mastery assessment for this chapter. However, I'm not expecting that you finish it. I just want you to put eyes on it, do what work you can, and then look at what you need to study or what questions need to be asked. When I come back on Wednesday, we'll regroup together to review anything that seemed like, oh crap, I didn't learn this as well as I needed to. We'll regroup, take any of those questions, any other homework questions, anything like that. Then we'll continue the mastery and hopefully finish at some point. So tomorrow my goal is just that you put eyes on it, that you put some time into it, that you work on what you can, and realize what are you still weak on. That make sense? So I know it's kind of like we normally don't go straight from like the last day of the lesson into the mastery, but because how the sub day fell, can't really, like, guys, think about it. If you send the random normal substitute who thinks he's coming to middle school and try to have them factor out quadratic polynomials, it won't be
It'll be
pretty.
great.
It
Oh,
won't.
can
We
Probably
film-
won't be pretty.
Like Mr. Hudson,
Yes.
Mr. Hudson, could
Yeah.
we film it and post it on AFB?
No.
Okay.
AFBs.
My dad
So-
was, how's school
It's
going?
on
And
video,
then
though.
he
It's
saw
not
this,
home
and then his
We're supposed to think of this as our home.
Are you studying
This is
Trinomial?
This is
That's
awesome.
cool.
Let's, hey guys, refocus. In our volume equation here, well, what do we know there have to be to get a volume? Well, 3 dimensions, right?
Yeah.
So what we normally call them length, width, and height, but we know there's 3 dimensions involved. So when I look at 6x cubed, 19x squared, and 15x, what's the first thing that we could do to this? Is there anything common that could come out of all of them? What do you think, Stradler?
I think. I can't see anything that can come out of all of them.
You're going to have a baseball moment.
Wait.
Strickland?
Oh, me? X.
X.
Oh, get
If the coefficients don't work together, check your variables. We can pull an x out of all of them.
Nice job, David.
X times 6x squared plus 19x.
No. Or yes.
Ah.
I was looking at the wrong thing.
So let's say I do make mistakes, but not that one.
I'm going crazy.
Now, can we do it by grouping?
You can do the whole. What's the thing we want to do?
Oh, you can do the 10x and the 9x.
The A, C, and B strategy.
So- To do this by grouping, I need to make 4 terms, right? Right now I only have 3. Well, forget about the x because he's just coming along for the ride. So right now I only have these 3 terms. So you were just talking about we can do the A, C, B thing. Explain what you're talking about.
So you do A, which is the thing in front of X, times
Which thing
C,
in front of x?
times C, which is the last variable.
Okay. So 6 and 15. So we look at AC is 90.
And then you look at B, which is the variable in front of just X, which is 19, and you have to see what 2 numbers for B, you have to see what 2 numbers add to get 19 and what 2 numbers multiply to get 9.
So sum to my B,
I know.
multiply to my AC.
I know. It's 9 and 10.
Dude does some crazy bobbies. It's crazy.
It doesn't matter what order you put these in. Because if you put the 10x first, you'll factor out 2x between it and the 6x. If you put the 9x last, you could factor out the 3 between the 9 and the 15. How I've done it, we'll factor out a 3 here, well 3x, and then we'll factor out a 5 here. You'll get the same answer regardless of what order you put them in. So then, go away. We get x times, I'm going to go ahead and start color coding this, between my 6x squared and my 9x, my common factor, 3x
X.
leaves me with x plus 3.
Is there any way to organize these that isn't so confusing?
Color. I mean, really, if you don't color code these things, it is fairly hard to keep track of what's what. 10x and 15, what can factor out of that?
5.
A 5.
Just 5, no X.
We get
So it's pink.
We can't see that color reduced.
That's the first one.
2X
Where is it?
plus 3.
Scarlet.
I made a mistake over here,
Oh, okay. I was
but
wrong.
nobody caught it there. Hold on, this is intentional. This is good. Because when I get over here, I'm thinking like, wait, this can't be x plus 3. What is going on? This has to be 2x plus 3, which when these don't match, a mistake has happened. There should be a 2 right here, which I didn't write.
Oh,
But when I get to this, it indicates like, hey, you screwed up somewhere. This needs to match. I don't know if he let it go, just trusting that I did it on purpose or what. But either way, these binomials have to match each other. If it doesn't work out, your factoring by grouping was not correct. You've made a mistake somewhere. So now this becomes x times, I like to use my shared binomial first, 2x plus 3, and then the 3x and the 5. Any questions?
No.
So, in case you have forgotten any of the process, I show that all right here. I think most of us probably didn't see it yet, but we can think about factoring out the x, then do your AC, which ends up to be 90. We figure out our factor list, and we find the 10 and the 9. From there, that's how I break up my middle terms. I group my left half, right half, doesn't matter where the center terms are. Find your shared binomial that's in common. Regroup. Any questions? Last thing to do, let's check out that 5. There's one more, got it, right?
Yeah.
C.
Try this. Give you about a minute to work on your own. Try not to look up here. $34.
Can I use my phone as a calculator?
Yeah, me too.
Yeah.
The calculadora.
Calculator.
That's fair, that's David.
Well, about to be a week.
2 minutes.
Someone figure out what factors we're going to use?
I know
Megan?
it.
5 and 12.
5 and 12. That's why I skipped the 5. I also skipped 3, but he didn't matter. So if I look at 5 and 12, those add to be 17. So that lets me break up my middle terms. And if you can remember to bring your 2x at the end, then I used to, and I know this is kind of against best mathematical practice, I used to like kind of put a star next to it and remember I got to bring this back and then only care about the trinomial, work that out, and then at the end put your 2x back on the front. Whatever process works for you is fine. So we use 30x squared plus 5x plus 12x, and order is irrelevant. Anybody have the final factored form answer of this because we are out of time? Megan?
2x and then 5x plus 2 and then 6x and so on.
Wait, Mr. Hudson, do you want us to find the factor before we pull out the 2x?
No. Pull out anything common from the entire thing before you, well,
Wait, because then that would be 5 times 12.
yeah, it'd be bigger. If you don't factor it to begin with, you're going to have the bigger value. Like, you want to factor out the common value first.
Oh, yeah.
Technically, you could go
30x
without
squared.
factoring. It's just a lot more inconvenient.
Ow.
Can we use the homework?
Yeah.
No, it has to be factors of a times c. So like 60.
You have to get to the point where there's a constant.
Which is why I'm saying, you want it should be factored before.
Yes, factor it before you find your AC. Again, I'm not expecting you to finish the mastery tomorrow. Just get your eyes on it, do some work on it. Have a great day, guys. I will see you for tonight. Yeah, evens and odds on tonight's homework. If you reach a point that you're confident, if you're still having issues, do some more.
Wait, was the last homework also even?
So if I'm
So.
confident now,
I'm
can
supposed
I
to
do
not have said that because I remember you
Write
saying
it on
that.
the top of it.
Actually, but I did it also. Go.
Nice. It is good practice. I mean, if it's not tough and if you have the time, it'll only make you
And then you
better.
did it again.